Hey guys, back for 19 through 24. Just remember it's important to keep in mind that you're not going to get all of these. You know, you're trying to get a third of them or a half of them, so try to keep your stress levels low as we go. Number 19 says f of x equals 2 cosine x plus 1. They want us to write an approximation for f of 1.5 found by using the line tangent. So as soon as I see tangent line, I think all I need is a point and a slope. And we're at x equals pi over 2, so my point has a value of pi over 2. If I plug a pi over 2 in, cosine of pi over 2 is 0, so 2 times 0 plus 1 is 1. Also need the slope, so I take the derivative here, and I get negative 2 sine of x. If I plug a pi over 2 into there, I get negative 2 sine of pi over 2. Sine of pi over 2 is 1, so I just get a negative 2. So I write my slope equation. Then I just solve for y, and I wouldn't distribute through there. I just add the 1 to the other side. So I get negative 2x minus pi over 2 plus 1. And now this tangent line is approximately equal to this function as long as we're near this place, pi over 2. So I'm now just going to plug the 1.5 into here. So I get negative 2 times 1.5 minus pi over 2 plus 1. If I distribute the negative 2, 2 times 1.5 is 3, so I get negative 3. This becomes a plus. 2's cancel, so I get a pi plus that 1. So negative 3 and positive 1 are negative 2, so I get pi minus 2, which is the answer. Number 20. So number 20 gives me a function, f of x equals x minus 2 over 2 times the quantity absolute value of x minus 2. Now, we saw these early in the year, but you probably haven't seen them for a while. When I look at this, the number that stands out in my brain is 2. So I ask myself, what would happen if I plugged in a value bigger than 2? So if I look at this quantity here, if I plug in a value bigger than 2, they're going to be the exact same. So it's going to be equal to 1. So if I'm looking at the right of 2, then I'm getting a value of 1/2 because of this 2 on the bottom, so it looks something like this. Well, if I plug in something smaller than 2, like a 1, a 0, a negative 5, any of those values, this is going to be negative, but this is going to be absolute valued positive, so I get that same value heading to the left, which means I have a jump discontinuity. If it's something you want to memorize, if I ever have the same quantity, one of them without an absolute value, one of them with, that's one of the ways we're going to get a jump in calculus. So that'd be a jump discontinuity at x equals 2. Next one says if f of x equals natural log of x, then what's this thing equal to? This problem's either impossible or easy, depending on if you see it or not. Now, if you look at it, you recognize that this right here is the slope between the point x, f of x, and the point 3, f of 3. So this is just a slope. It's just y2 minus y1 over x2 minus x1. But as x gets closer and closer to 3, essentially those points are coming closer and closer together. So we are just calculating the slope at 3. So we can go back up here. We can take the derivative, just 1 over x. So at 3, it's simply 1 over 3. So you have to do a little thinking and recognize that as a slope equation. It's not the one we've always used. But it is a different version of the limit definition of a derivative. This one is a pretty hard problem, especially since this is new content. So if you want to just skip this part, that's fine. If you're looking to get a 4 or 5 on the test, you might want to stick around. So I'm going to separate my variables. I'm going to bring this y over here. Since this is multiplication, I don't have to bring the 2 with it, so I'm not going to. So I'm just going to divide both sides by y and multiply both sides by dx. So I'm going to then take the antiderivative of both sides. So this side I get natural log of the absolute value of y. I'm not going to use a plus c over here because I'm going to put it over here. Over here, the way that gets to the bottom is with the natural log of 2x plus 1. And then if I take the derivative of this, I get that 2 in the chain rule, so this worked perfectly. I'll do a plus c. Next goal, like we worked on yesterday, is getting this absolute value of y out of here. So I'm going to do e to all of this equals absolute value of y. You'll be surprised when we go through this how quick this becomes commonplace. That plus c right there can become an e to the c by itself, which is just a number. So we're going to reference that number as an a. So if we move over here, I'll have absolute value of y equals a e to the natural log 2x plus 1. If absolute value of y equals this, then y equals plus or minus this, as we saw last time. And it's only going to be one answer, so we're going to say whatever that plus or minus a is just going to be some number, we'll call it b. Okay, so this is our general equation. We've got to get into specifics. It says when we plug a 0 in, we get out an e. So I'm going to go ahead and plug that in. So b e to the natural log, if there's a 0 here, that's just a 1. Natural log of 1 is 0, e to the 0 is 1, so b is just equal to e. So y now equals e times e to the natural log of 2x plus 1. And now if you have e to the power of natural log of something, this whole quantity just equals this. So now we have y equals e times 2x plus 1. If we distribute, we get 2ex plus e, which is answer B. Again, if you're trying to scrape by with a 3, let this one be, all right? Number 23. So 23 says we have y equals x squared and y equals 2x. So we need to figure out when these meet. So you can either set them equal to each other, or if you just happen to see it, I see that it's at 0, 0, and up here at 2, 4. If not, just set them equal to each other, get them on the same side and factor. And it says we're going to cross-section perpendicular to the y-axis. So as soon as I hear cross-sections perpendicular to the y-axis, I know that I have to change these equations. So this is going to become x equals root y, and this is going to become x equals 1/2 of a y. And I have rectangles that are 3 times as tall as they are wide. So if we think about the length of this base, I take right minus left, so that's root y minus 1/2 of a y. And this part here is 3, that quantity. So 3, if I take this times this, I get that quantity squared. I'm not going to worry about simplifying it. And then I'm going to plug that into an integral. Looks like they took the 3 and put it outside. And I'm going y, so I'm going to go 0 to 4, not 0 to 2. Which makes it answer A. And number 24 says if the average value of a continuous function f on negative 2 to 4 is 12, so we're just going to start there. So if the average value of this function on negative 2 to 4, you'll recall we do average value by taking the integral divided by the length of the interval, and that's equal to 12. So my goal here is to solve for this. So I multiply both sides by 6, and I get that this quantity here is equal to 72. That's what I know. The integral from negative 2 to 4 of f of x dx equals 72, because this integral divided by 6 equaled 12. And they want to know what's this equal to. So, sorry, not equal to 72. They want to know what this is equal to. So this 8 can be factored out as a 1/8. And this quantity here is equal to 72. 1/8 of that is simply equal to 9. So just start with the given information to figure out what the integral is equal to. Okay, I'll be back with the other set here in a few.